Hello world and welcome to another UI Toolkit video. I am Roman and today we're going to look at how to implement a radial fill element with UI Toolkit in the 2021 LTS version of Unity. Today I'm changing the format of the video, so it's not an in-depth video on the topic where you code along, but more of an overview summary of how things will work with the code being provided in a GitHub gist. So let's talk about today's custom element, a radial fill element. If you've been using Unity for a while, you've probably already come across it in the old Unity UI solution, where you could radially fill an image. These are used as an element of communication for progress. Things like ability cooldowns in MOBAs and ARPGs are just a couple of examples. But in UI Toolkit, you might have noticed that this feature does not currently exist. But it is a feature they are working on. In the interim, though, I thought I'd experiment on how to get that done with the tools we have available for us in the 2021 LTS version of Unity. So let me show you how this radial fill element works. In UI Builder, just drag in the radial fill element, which will appear as a little white square. Now, in the inspector, we have some attributes we can change. So I'm going to set the width to 200 and the height to 200. And there is a value, and if we put this value as 0, it's obviously unfilled. And we drag this along, you can see it radially filling when the value reaches 1 and over. You can also set the fill direction from clockwise to anti-clockwise. So I'll set this to 0 again. This time when I fill back to 1, it'll fill in anti-clockwise. Set this all the way back to 0 and under. Now, if you wanted a more circular looking visual element, what you would do would change the overflow to this section option here, which is hidden. And then you'd also change the border radius to whatever is the largest between your width and your height. Since ours is the same, I'm just going to put it at 200 for the radius. So now when I fill it, it'll fill as a circle. I'll set this clockwise. You can also set a background image. So I'm going to set the background to this. And I'll set the fill color to something more like, I don't know, that. I'll put this anti-clockwise. So at 1, it looks like the button's not ready. But when we go to 0, it looks like the button's ready to be pressed. Isn't that neat? And also, you can set an overlay image by setting the path to this field here. So that's easy to do just by going to whatever your image is and copy the path. I'll go back to UI Builder and I'll just get rid of this image here. And I'll just set the color to white. Now I'll copy the path into here. And I'll set the fill color to this red color. And I'll put a border width of 2, make color black. So it's got you can see a black border around the circle now. And this time we'll fill in clockwise. So now when I go from a value from about 0 to 1, ta-da! Now it looks like that like button is ready to be pressed. set it all the way to clear. There you go. And one other thing you can do is you can also change the angle offset for the filling. So to demonstrate this more clearly, I'll just get rid of this image front. I'll go back to 0. So the offset goes around clockwise, so 0 is up the top. This would be 90, 180, 270, and then 360, also 0 up the top. So I'll set the angle offset to 90, and now when we fill it, it'll fill from that right side. Offset to 180, it'll fill from the bottom. Yeah, like that. And I'll just reset this back. Now I'll just show you the hierarchy of this element. So radial fill element, we have 3 visual elements which make it up. You obviously know the overlay image is the frontmost visual element. There's a radial fill element, which is basically the thing which is drawing the fill. And we have a radial boundary. That comes into play because in this display option here with the overflow, it has it set up so that the option is set to hidden, so it'll hide any of its child elements rendering cannot be shown if it exceeds the boundaries of the visual element. And of course you just have the parent, where you can set the border to have a radius, which would make it look more circular. And if we just get rid of this radius, it just go back to being a square or rectangular. I'll just unset all this. Come on. So this radial fill visual element also works runtime. So I'll just demonstrate that. I'm just going to basic scene where that's the radial element there. And I have a test value, which I can just go from 0 to 1. So I'll just play this. Change the value. Yeah, it works in runtime. So now I'll just go through the code and show you how that works. Script, radial fill element, inheriting from visual element, and you'll notice that I'm using the iNotify value change interface. So what it does by default, when you set the value, it'll just make this radial fill visual element mark dirty and repaint. In here, we have our properties, which were set up as UXML attributes. So your width, height, fill color, the angle offset, the overlay image path, the fill direction, and the overlay image scale, which just allows you to scale the image at the front. Here are the UXML attribute descriptions for those C# properties. Here is where we assign the UXML attributes to our C# properties. And here is where we create the hierarchy for the radial fill elements. So if you remember, we had the radial boundary, the radial fill, and the overlay image. Beneath there, we're setting the flex grow to 1. So it'll just stay there, grow to the size of the parent. And we're also setting our height and our width to whatever's being put in as our attribute in the inspector. And this is where we set our overlay image path to create put the foreground image in. I'm also using the if preprocessor directive. So So this will compile and it won't show up as an error for the Unity editor. Because usually you'd only do all this setup in UI Builder. And here's just the code for the angle offset. So the main basic functionality comes in this section here, which is the on-generate visual content. So with UI Toolkit, we're able to create a mesh, and I'll demonstrate this in a paint. So visual elements have an on-generate visual content callback that we can subscribe to, which gets called every time that the visual element gets repainted. So we can use the MeshWriteData object to create a mesh for us. So remember before where we had that option called Overflow hidden, which would just make it so that our child objects or our child visual elements can't have their visual rendering exceed the boundary of the parent. We are using that to do our radial fill. So just imagine that this is our visual element. Now, to be able to fully fill that element, we would need a large enough triangle. Oh, that's obviously not going to be left. Fit in there. There we go. I can move that. So with overflow hidden, if we filled this triangle, it would only stay in the boundaries of this visual element here. So that would be fully painted. But we can't just use one triangle to do the radial fill. So the minimum we would need is 3 triangles. Draw a triangle here. You make that bigger. And a triangle here. And triangle there. Just pretend that's in bounds. So these triangles cover up to 3 degrees, or 3 sets of degrees. So this would be, I need a brush. Yeah, that's not thick enough. Okay. So this is 120 degrees here, 240 degrees here, and up the top is 360 degrees. So if we fill this way, we can do the whole radial fill with just 3 triangles. So say we only wanted 45 degrees, and this whole first triangle would just only draw to here. But the whole range that the triangle can draw to is a degree of 120 degrees. So we have our value property, which goes between 0 to 1. And 120 degrees represents about 0.33 of our value. And 240 degrees represents about 0.66 of value. So these are the breakpoints. After we exceed 120 degrees is when we have to start drawing the second triangle. And after we exceed 240 degrees is when we have to start drawing the third triangle. So the minimum triangles we need is 3 triangles to represent the whole 360 degrees. So let's go back to the code. As you can see here, we're just determining whether we draw 1, 2, or 3 triangles to cover our range of radial fill. In here, we have to allocate how many vertexes we're going to draw, as well as the indices which count for how we draw those triangles. If you're familiar with drawing meshes, you know that you'll need to set up the indices so they go in a clockwise motion. So since this is, since the UI is just drawn basically two-dimensionally, we have to set our indices clockwise, or else if we don't, they just won't show up at all, and they'll potentially just be the back faces of them, but the back faces don't get rendered. So back into our painting, let's draw our first triangle. This is going to be vertex 0, the top is vertex 1, and the bottom right is vertex 2. The position for our vertex at indices 0 and 1 can always stay the same. It's only the second one which actually just changes position. So vertex 2 could be here if it's at 45 degrees. We go back to the code. We're drawing those two vertex here. Now, it became complicated when I wanted to implement the anti-clockwise direction filling. So that's why we're using this ternary operator here to change which way our indices are declared. So for anti-clockwise radial filling, we'd have to draw the triangles in a different order. We would start from this triangle to this triangle and finish with this triangle. And the indices would become 0, 1, but this one would become 2 here. Well, this vertex would be 3. But to still declare the indices in a clockwise motion, to make this triangle visible, the indices would become 0, 2, 1 to draw this triangle, and then it would be 0, 3, 2 to draw this triangle, and then finally 0, 1, 3 to draw this triangle. However, in the case that the radial fill anti-clockwise is between 240 degrees and 360 degrees, then you would have a fourth vertex. Let's say it filled from so let's say reach around here. Our fourth vertex would be here. And then we just go 0, 4, 3 to draw that triangle. So here you would see set index 0, 4, 3. So that brings us to the end of the code. I've posted this script up on GitHub as a gist. So you can copy pasta this script if you like, but I'd mainly only use this for Unity 2021 LTS, because in the 2022 version of Unity, there is a new vector API, which does have a simpler way of drawing things. But it was a kind of fun experiment to try and figure out how to implement a radial fill element for the 2021 LTS. And I hope you manage to get some good use out of this script if you do intend on using it. This is bye from me for now, and I hope to see you in the next video. Peace.